Okay, let's keep going with our exponential functions, where we're looking at exponential growth and decay, trying to figure out our domains and ranges, and looking for the patterns. So we're going to start with a function today that we need to identify the pattern and try to come up with our y-intercept, our growth rate, and our function, figure out our domain and range, and graph it. So what is happening in our table? Really, the only side we care about is the y value. So that's this side. So what is happening from 50 to 10, from 10 to 2, from 10 to 0.4? Well, I know that to go from 50 to 10. So first of all, the thing that I notice is that this is big up here and this is small. Okay, so I know that has to be a division pattern. Okay, it has to be a division pattern. So I see that from 50 to 10 and 10 to 2, that's divide 5. And I know that if I take 2 divided by 5, I'm also going to get 0.4, and 0.4 divided by 5 is going to give me 0.8. So my pattern is division by 5. Okay, that's my pattern. So remember that the pattern and the growth rate, they're connected. Okay, they're connected. But I can't write my growth rate as a division. I have to write it as a multiplication. So I have to write it as a fraction. So a division by 5 is actually a multiplication by 1 over 5. Okay, so if I see a division pattern, it's going to be a multiplication by 1 over 5. So that's now my B. All right, the y-intercept. Well, remember, your y-intercept is where it crosses the y-axis, and I see that I always have to have that 0. So my y-intercept is a positive 2. Okay, my y-intercept is a positive 2. And remember from yesterday, my function is a times b to the x. So this is going to start out at 2. It is going to drop by 1/5 every time, and I have a power of x. So let's go ahead and graph this. So -2 and 50 is way up there. I can't graph that. -1 and 10 is going to be about here. 0 and 2, 1 and 0.4, and 2 and 0.08. I see that it's coming down. Remember, these are curves, and it's going to hug this 0 line. Okay, it's going to hug that y-axis. So the first thing we should see is that this is a decay because it's going down. Okay, and if I am going to think about my domain and range again, I need to kind of mark where that tail is. I see that it's hugging that x-axis, so I know that I'm going to be real numbers less than 0. Oops, sorry, not less than, greater than 0, because it is above 0. Okay, it's still going to be above 0. It's going to approach 0, but it's still going to be above the 0. And my domain, again, is going to be all real numbers unless it is a word problem. And we're going to take a look at a couple word problems today so you can kind of see the difference. Okay, let's see if let's do a multiplication one and see what happens. So go ahead and hit pause. See if you can figure out your pattern, your y-intercept, your growth rate, your function, your domain and range, and sketch your graph. And this time you're actually going to have to do a little math and figure out what that top number is. All right, so let's see what happened here. So first of all, I notice that I'm going from small to big. So I know this has to be a multiplication pattern. Well, if I'm not very good at figuring out patterns, how can I figure out like what's going on? Okay, so if you think back to when we talked about patterns, we talked about how you can take the two numbers and do some math with them. So we're going to go ahead and divide. We're going to take our big number divided by our small number. So we're going to start with 405. So 405 divided by 135 gives me 3. Okay, I'm going to do it again. I'm going to take 135 divided by 45. That gives me 3. I'm going to do it again. 45 divided by 15, and I get 3. So I know that if it's going to be, if I'm going this way and it's division 3, this multiplication by 3 is what's happening going down. Okay, so my pattern is times 3. Well, I need to come up with this value. So what number times 3 is going to give me a 15? And remember, you're working the opposite direction. So if this direction is times 3, this direction we already know is going to be division. So if I divide by 3, 15 divided by 3 is going to give me a 5, because 5 times 3 is 15. So I know that my y-intercept is 5. Okay, so growth rate and pattern, remember, those are the same. So my b is 3, and my function, a times b to the x, I'm starting at 5. I'm going to multiply by 3, and it's a power of x. Okay, and domain, that's all real numbers. That's pretty easy. And let's go ahead and take a look at this function and kind of figure out what's happening. Okay, so let me get my Desmos graphing here. I've got my f of x equals 5 times the 3 the power of x, and I see that it's going up and it's approaching 0, which makes sense because if I start to graph this, 0, 5, 1, 15, I see that it's going up really fast. Okay, it's going up really fast. So what do you think our range is? Well, here's my tail. Am I above 0 or am I below 0? Am I above or below 0? Yeah, I'm above 0, so I've got real numbers greater than 0. Real numbers greater than 0. Okay, so let's kind of put this into play because exponential functions are actually one of the most commonly used functions or mathematical tools that is used in everyday life, because every time you pay interest or you take out a loan or you buy a car or you deposit money into a bank and you're going to let it pay interest, it is going to grow exponentially. And something that happened that we're living through is the coronavirus, and that coronavirus grew exponentially. So it didn't just start out with one person and then add another person. It started out with one person and then added 10 people or 50 people or 100 people. It grew really fast. Okay, it grew really fast. So we have to be able to develop the function and then use that to kind of estimate values. So we're going to take a problem like this one. It says we purchase a car for $24,000 and it depreciates in a value. Depreciates means it goes down in value 16% per year. So depreciates means goes down, okay? So it's losing money. And it wants to know, what is the value of my car in 4 years? Well, we have two formulas we're going to use. We're going to use 1 plus r and we're going to use the 1 minus r. So you'll see that our b got replaced with this 1 plus r, 1 minus r. Well, what's r? R is our percent as a decimal. Okay, R is the percent as a decimal. So we need to figure out, if I have 25%, that is 0.25 as a decimal. Remember, I need to move it 2 places to the left or I'm dividing by 100. Okay, so if I give you 4.2%, that is 0.042. It has to move 2 spots, 1, 2. So there has to be a 0 here. So the first thing we have to do is change our percent to a decimal. And then we have to decide, is it a growth or a decay? Because our top one is growth and our bottom one is a decay because we're subtracting. Okay, if we're adding, it's growth. If we're subtracting, it's decay. So let's read our problem. Let's try to figure out these numbers. Okay, and we have to then write our function and figure out our values. We're going to make use of our calculators to kind of figure out these numbers. So let's start with purchasing a car for $24,000. Well, that's my initial amount. Okay, when I buy my car, it is worth $24,000. That's my starting point. Well, the growth rate, okay, if it's a decay, it means I'm going to use this 1 minus r. Well, let's change our decimal. So 16%, or change our percent to a decimal. If I move my decimal 2 spots, that's 0.16. Okay, 0.16. So my growth rate is going to be 1 minus 0.16 because I am subtracting. Okay, I'm subtracting. So my function becomes 24,000, the 1 minus 0.16, and I still have my power of x there. Okay, so now we're going to look at this a couple different ways. I'm going to start with looking at my Desmos scientific calculator. Okay, my Desmos scientific calculator. And we're going to put this function in. And instead of using the x, we're actually going to put in the years. So the 0, the 1, the 2, the 3. Well, we already know the 0. That's 24,000. So we're going to start with 24,000. We're going to put in 1 minus 0.16. And I'm going to get my power. Remember, you can do that 2 ways. You can either use your a to the b. And I'm going to start by putting in a 1. And I see that the value of the car is 20,160. So 20,160, which makes sense because the car is losing value. It's going to be less every single year. So I've lost a little over, or just about $4,000 in value of my car. Okay, so let's change this 1 to a 2. And I see it says 16,934.4. Well, it's money, so I can actually use that decimal. 16,934.40. So $16,934.40. So this time I lost more than $4,000. You can see how it's actually losing more. I should take that back. Not quite $4,000. It's going to be closer to $3,000. I lost a little bit less because I'm starting out with a little more. Now let's try a 3. 14,224. And let's round that off. That would be 0.90, so 90 cents. And then the next question says, find the value in 4 years. So we're going to go ahead and put a 4 in there. And I see that this is $11,948.91 because that 2 is not going to make that any bigger. Okay, it's not going to make that any bigger. Now let's look at this with my Desmos graphing calculator. So I'm going to go ahead and take this out, and I'm going to put in my f of x equals the 24,000. This time I'm going to put it in with the x. So 1 minus 0.16 and caret x. Okay, so obviously I'm not going to see the graph at the moment because I'm at 0 and 10. What I want to see is the table. Okay, so I can see the same numbers on the table, and I can do a 3 and a 4 and get those numbers. So whichever way you want to find the numbers is entirely up to you. If you want to type them into the Desmos calculator and just change your exponent, or if you want to type them into your Desmos graphing calculator, you can actually go to the table and come up with all your numbers. Well, so let's talk about domain and range this time. So I'm going to go ahead and make this bigger, and I'm going to zoom us in so we can see what's going on here. So I see that my graph is coming down, and it's going to go to that 0 line. Well, this is a word problem. So we said that on word problems, things change because there may or may not be a use of every single value of x. Okay, so if I think about what's going on here on my graph, these are years. The positive 0, 50, 100, and obviously I'm not going to keep a car for 50 years. Well, maybe not. I'm definitely not going to keep it for 100 years, probably, of these new cars, but I might keep it for 10 years, maybe 20 years. Am I going to have negative years? No. So this actually starts, if you take a look at my graph, my table, my x values started at 0. And it increased. So my domain this time is real numbers greater than 0. Okay, greater than 0 because I started at 0. That is my starting point. I am not going to have anything that is negative in my domain, because it doesn't make any sense to have negative years. My range, well, it's got a top. It's starting at 24,000. So my range is going to be real numbers less than or equal to, because it can be equal to $24,000. 24,000. So it actually has a top and it goes down. Okay, so if I'm talking about a word problem, these numbers matter. Okay, they matter. The 0 is going to control my range, and it's normally going to go above that or below that. And then the 24,000 is either going to go above that or below that. Okay, now the kick is that it is also not going to go into the negatives. So my real number has to be greater than or equal to 0. Okay, so I could actually write that as a compound inequality. I could write it as an and, because I'm greater than 0, but I'm less than or equal to 24,000. Okay, and sometimes you might see it where we don't have the equal to with the 0, but it can be written as a compound inequality, an and inequality. All right, let's look at another one. Okay, so this time we're going to be putting money in a savings account. Okay, we're going to put $200 in a savings account, and it's going to increase 3% annually. So at time 0, I have $200 in my account. Okay, so my y-intercept is 200. That is my starting point. Now, am I going to use 1 plus r or 1 minus r? Yeah, it's growing, so I'm going to use the 1 plus r. So 1 plus, well, 3%, if I divide by 100, is 0.03, 2 spots, 1, 2. So plus 0.03, that is my growth rate. Okay, so my function is going to be 200, the 1 plus 0.03 to the power of x. So why don't you go ahead and pause for a second, use your calculator, see if you can figure out the values of 1, 2, 3, 4. How much money will you have in 4 years? And again, it's your choice in terms of how you want to do it. I think I probably will use the regular calculator this time. So I'm going to go ahead and clear this. All right, so hit pause. See if you can come up with those values. All right, let's see how you did. So I have my function, and I'm going to put in my first value. It does not like that. So I'm going to do y equals to see if I can have better luck this time. So 200, 1 plus 0.03 to the power of 1. So I have $206. $206. So I increased by $6 this first time. Let's change that 1 to a 2. I have $212.18. So $212.18. So I actually got $6.18 that time. And if I change this to a 3, I'm at $218.55. Now round that off. This 5 makes that 4. It's money, so round off to 2 decimal places. And if I change this to a 4, I see I have $225.10. $225.10. So in 4 years, I have $225.10. Okay, so domain and range. Remember, we're looking at what's going on with our values in our table. So we're starting with x, and it's years. So it doesn't make any sense that we're going to have negative years. So the domain in this case is going to be greater than or equal to 0, because I'm starting at 0 and I'm going up. And it might end if I take it out at year 20, but at this point, we don't know how long the money is going to stay in there. It's just going to be real numbers greater than or equal to 0. Well, what about my range? Where am I starting? I'm starting at $200. Okay, so I have real numbers and I have $200. Am I going up or am I going down? Yeah, I'm going up. So since I started out with $200, I can put the equal to in there, and I have greater than or equal to 200. Now this one does not stop. I don't have a limit. Like the car one, I know the value can't be less than 0. So it was between 0 and 24,000. This one, I'm at $200. I'm going up. I don't know where I'm going to stop. So the money is going to keep growing. Okay, so give it a shot today with your homework. Reach out to us if you're struggling. We're going to spend tomorrow also looking at these exponential functions and making sure that you're really good at evaluating. Remember, you can use either the Desmos calculator to get your table or Desmos Scientific to just get your values. And we'll catch up with you tomorrow.